formula sheet of current electricity. When resistors are connected in series, there is only one path to the flow of current, and same electric current pass through each resistor. And the total resistance or combined resistance of the circuit can be calculated by their simple addition. But if the resistors are connected in parallel, then there are many paths to the flow of current. And in parallel combination, PD, potential difference across each resistor, is same. And we can calculate the combined resistance of the circuit by this formula, or 1 upon R equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3. But the formula which I have shown, I think it is more easier way to calculate combined resistance. And now when resistors are connected in series, then we can call such circuit as potential divider. This circuit can be known as potential divider because in this circuit, the potential is divided. So it is known as potential divider circuit. And in potential divider circuit, the voltage or potential difference across R1 can be calculated by this formula, and where V is the EMF of cell. In the same way, we can calculate V2 by this formula, whereas V is the total EMF of the circuit. So it is the formula of potential divider. In parallel combination, current is divided, and it is also known as current divider. But usually in O levels, this formula of current divider is not taught. And now we are going to study energy calculation. You know that the electrical energy is the product of potential difference and charge. And if we divide both sides by time, then rate of energy is called electrical power. And electrical power is the product of voltage and current. Electrical power is very important, and it is the product of voltage and current. But sometime you are not given voltage, and if voltage is not given, then we can eliminate V by IR. So another formula to calculate electrical power is I square R. So the common formula power, voltage into current, and the second power formula is I square R. And we have another formula to calculate electrical power. If current is not given in a question, then electrical power is equals to V square upon R. And whenever you have to calculate electrical energy, then electrical energy is the product of power and time. And we can replace this power by voltage, current into time, and sometime I square RT, and sometime V square upon RT. So electrical energy can be calculated by the product of power and time. And the basic formula of power is voltage into current. The unit of electrical power is watts or kilowatts, but the commercial unit of electrical energy is kilowatt hour. And usually we convert power into kilowatts and usually time in hours, and then we can calculate kilowatt hour. And if you are given the cost of 1 kilowatt hour, then we can calculate the cost of any given kilowatt hour. So but it is a formula sheet of current electricity, and if you memorize these formulas, and the very important formula of this chapter is voltage is equals to IR, it is Ohm's law. Current formula, sir, it is the rate of flow of charge. Potential difference, basic formula, work done per unit charge. Work done per unit charge. So these are very important formulas, and you must memorize these formulas in order to solve past paper questions. Thank you.